Okay, so where we left off in class last time is we defined this thing called the definite integral or the Riemann integral. So just to remind you, the Riemann integral, the Riemann integral, which is also sometimes called the definite integral. That's what we defined last time in class, and it had something to do with areas. So if the function is positive, it really is the area under the graph. But if the function is positive and negative, it was, we called it the net area. And this is what it looks like. So this was the symbols we used. And all of these things are equal. They're all equal to the net area between x equals a and x equals b of some graph f. And that was defined. There was a story about a limit and doing base times height and doing the rectangles getting smaller and smaller. And it was a certain limit. So maybe that's worth writing down. Limit of the Riemann sum. So this is the one line summary of last class, chapter 11.1. We're now going to do some properties of this thing. So, this thing is a mathematical object. It's a limit of a certain thing. And because limits obey certain rules, therefore, integrals also obey certain rules. And we're going to go through a few of those. So that's what's coming up next, that we're doing now. So properties of the definite integral. So given our definition, we can determine a few important and mostly intuitive properties of the definite integral. So if you have this intuition that the integral is equal to the area, and you know how areas behave because you're a human that lives in the world, you can get some intuition about like formulas for integrals. So here we go. Here's the first one. For all of the following, so there's going to be a list of these. There's a whole bunch. But for all of the following, k, a, b, and c are just constants. So, they're any constant you want. A is less than b is less than c. And f and g are presumed to be integrable functions. So, for example, any continuous function is integrable. Okay, so here's the first one, property one. Property one. And the property one is a nice formula for the integral from a to b of k dx. Okay, so that's equal to something. And I let you guys do that in Top Hat, so take a stab at it. And I think to do this one, what you should do is you should draw a picture of the graph. So f of x equals k here. It's the flat function. So here's k. Here's k. Here's x equals a. Here's x equals b. And we're talking about the area. So we're talking about this area. So I think if you use that intuition, you can figure out this formula on your own. Okay, so let's pause the video and you go try that Top Hat question.